thank you very much for coming. It's the talk about Kotlin goodies for testing. You can imagine that this talk is about, yeah, I just said it. I'm Pasha Finkelshteyn. I work at JetBrains. I'm developer advocate. And well, I tried a lot of stuff in my life, and I like emojis, as you can see, or icons. You can call them Kotlin, Java, Scala, Clojure, Ceylon. There is no icon for Ceylon, and hopefully nobody knows what Ceylon is. And yeah, I like to get this to tell this because people are still coming in, and nothing important. They don't lose anything important. I also have some experience with Python. I like Python. I know that many people, many folks who use Java, they think that Python is rubbish, but I worked in data engineering, and there Python is actually very interesting and promising. Yeah, but it works on top of Rust or C or C++ or whatever. These days, mostly Rust and C. I was a data engineer, and also I'm a speaker and streamer. You can find all these weird emojis, but basically you can go to JetBrains Twitch and find my stream about writing a game in Kotlin. Because, well, game development is barely existent in Kotlin, right, and in JVM at all. Everybody writes games either in C# or in C++. But actually, it's very possible, and it's very interesting to write it in Kotlin. There is a library called KTX, and I highly recommend to check it out. I know that you don't remember the name. Come to me after the talk, and I will showcase to you. Okay, but one thing I learned during my whole I don't know, experience, that code breaks, and it requires testing. And this slide is actually a code that is broken. And yeah, hopefully it's my promise, but probably I won't keep it. But I try really hard. During this talk, you will learn some things about testing. Maybe you will learn some things about Kotlin, or you will learn Kotlin. Are there people who are not familiar with Kotlin at all here? Okay, one person. I hope that for you it will be even more interesting than for others because, well, completely different syntax, completely different experience. Maybe some techniques, maybe I know, maybe I will mention something in this talk what you are not aware of or you didn't try. Maybe some tools or libraries, frameworks, whatever, and maybe some ideas. If you are using completely different language, I don't know, Haskell, probably you can reuse ideas from this talk in your code with your syntax, and who knows, hopefully. There is a problem with most test code bases I saw. This problem is tests are not as documentation, they don't look like a documentation, they are not very readable, and they're very flat. Like we have test class and lots of test methods in it. And I don't like it. I think that tests should be structured better. And how can we structure them better? We can do it using DSLs. DSL stands for domain-specific language. It's the abbreviation JetBrains uses all the time because Kotlin is amazing in building DSLs. What is domain-specific language? It's a language, subset of language that allows you to describe your domain better. We'll jump back in it in a couple of minutes. Structuring our code better, well, it may be about classes, it might be about functions, or whatever the unit of testing is in your code. Or using smart libraries. Libraries can really help us writing more maintainable, more readable tests. Marit has a talk tomorrow about how to read code, right? Because in this talk, I'm trying to tell how to write a readable code, but you still need to read it. So yeah, go to her talk too, please. And speaking about DSLs, one of the most well-known DSLs in the testing world is BDD. Who knows what BDD stands for? Almost everybody, but just in case, it's behavior-driven development. And it introduces 3 keywords like given, when, and then. And we usually want to define behavior or some real-life application in these terms. Who likes it, by the way? Who likes BDD? Half of the audience, maybe even less. I don't like it either. So I'm in the second half. But still I know that you are here, and I appreciate that you know how to use the thing. So given something, when something happens, it's given is precondition, when is condition, and then is outcome. We can describe basically any usage scenario in these terms. And there is a very well-known language for that. It's called Gherkin. It looks like that. It has features and scenarios and given, when, then inside it, and also end. Look at this. Isn't this code readable, by the way? Yeah. Yes, Marit.
I want to answer what's the problem here.
Yeah, what's the problem here? Yeah, what's the problem here? No, don't.
It's too many implementation details. It's not describing the behavior.
Yes, but for me, problem is even a little bit different. For example, this line, it can intersect with any test, at least on JVM, in JVM implementation, because, well, this is how Cucumber JVM tests look. For example, and press OK button. Tests are matched by the string, which is not completely type-safe thing, and there are lots of OK buttons in our web application. So only one function will be called, and I don't like it. I mean, it's not how it should work, in my world at least. And I think that we can do it better, at least a little bit better. For example, on the right side, you can see the library Cotest, and I will be showcasing the Cotest library today a lot. So there is a style of testing in Cotest which is called behavior spec. On the right, you can see an actual web page of Cotest. On the left, you can see my own code, my own snippets. And there is some difference between this code and code from Gherkin. There is no plain text files with given, when, then. Of course, IDE can help you with them a bit, but, well, it's a real code. And it will execute it in given order, which is very cool. There is no string matching. Strings here work only to describe what's going on in our behavior test. And everything is in one place. We don't have to run over dozens of Java or Kotlin files to find where is my given implemented. And here's how it works. We have class, so it's called myTests. It extends behavior spec. And given something, when something happens, it's my tribute to Harry Potter, actually. I like these books. Then something else should happen. And of course, you can have as many givens as you need. And you can have as many thens as you need. And inside them, you'll write your code. Yes, it's deeply nested, but it has some bonuses to it. For example, you can fold some blocks if you're not interested in them. I don't know. For example, fold this one, fold the whole given, and say, I know that inside this scenario, we will be talking only about broomstick. There are also different flavors of testing in Cotest. For example, this one is called describe spec. If I'm not mistaken, it's something from JavaScript. JavaScript, yeah, thank you. And it describes things and then defines its behavior. For example, describe something, then it. Inside it, you will have your testing code. Then describe something else, and inside it, you will have some testing code again. And it can be deeply nested as you need it, actually. And I think it's beautiful and gives a nice structure to your tests. Who works with JUnit? And me too. And I like JUnit, actually. Who thinks that it's the correct JUnit? Okay, Almost nobody. Yeah, it's correct, JUnit actually. It still extends class annotation spec, and it's very useful when you want to migrate from JUnit to Cotest. You can just extend class called annotation spec and have all your annotations in place. Runner will be different, but syntax will be actually the same. You'll also need to replace some package names, but it's semi-automatic action, which you can do once in your project. So yeah, we have all these nice keywords like before each, and obviously we can have functions for testing, test, and so on. And there are lots of shades of this Cotest. Actually, there are 11, but I didn't fit the last one here for some reason, for a known reason. And they all feature the same thing. They allow you to structure your tests in a way that you like it. They do not dictate you anything, and you have choice how to write a readable test. Let me show you a small demonstration. So I have a small domain knowledge here. We have a class called shopping cart here. It contains a list of items, and items are pairs of product to integer. Product is obviously a product with its price, and integer here is amount of these products in my shopping cart. For example, if it's 3 soaps, it will be the product will be with name soap, price will be something, and this int will be 3. And also shopping cart contains a discount. Discount is, again, this question mark means that discount is nullable, because sometimes I do not have any discount. But if I have discount, it has discount kind and amount. By the way, Marit said to me that discount kind is not a nice name, so I have refactoring to quickly fix it from discount kind to discount type. Yeah, and discount types can be obviously of 2 types, flat and percentage. Flat is when we just remove some part of our price, and percentage is relative. It should be between 0 and 1, and we will discount some percentage of the total price of our shopping cart. Here's the code that works with the shopping cart, and it actually calculates the final price. What do we have here? We have here total sum equals cart.items sum of. Who understands what's written there? Okay. So sum of is aggregation that sums something inside collection. Items is a collection of our products, and then inside lambda we have 2 arguments, obviously product and count of each product. Then we take each product's price and multiply it by amount of this product. Why is it big decimal? Who knows why it is big decimal? Because you should never work with money in doubles. And I hope that if you remember only one thing from this talk, you never work with money in doubles. It's even more important than any testing, because you will have bugs with it. That's why I use big decimals. And by the way, big decimals are much more beautiful in Kotlin than in Java, because you have all your usual operators like product on them. Okay, so first I count the total sum, the total amount for my shopping cart, and then if there is no discount, I just return the total sum. If discount is flat, I should probably rename this kind to type 2, right? Thank you, idea. It was fast. I remove amount from total sum, and if it's percentage, then I multiply total sum by 1 minus amount. I believe they're correct, but as any good developer, I have tests. Let's run them. And while they are running, we'll look at them. It's feature spec. I like feature specs because they describe features and scenarios in them. So I have several features tested, flat discounts, and they should be able to discount the whole product price to 0, and they also should be able to discount half of the price. And percentage discounts, well, obviously. Let's look how report looks. Well, it's actually beautiful. I like it. It's structured. That's what I'm talking about. We have flat discounts and subtests, and percentage discounts and subtests. And also, as any good developer, I have fail tests. Okay, what we can vote here really quick. I can skip them, or I can fix them. Who is for skipping? Who is for one person? Who is for fixing? Many people are for fixing. Okay, then we'll have to dive a little bit deeper in our tests. By the way, look at this nice feature. It's X scenario. Scenario is just running. X scenario is automatically skipped. Okay, what's it about? It's about general shopping rules. Discount can be negative. Discount cannot be negative. And I still can quickly fix strings. Isn't it beautiful? Price cannot be negative for any product. And amounts cannot be 0 or less. I mean, if it's zero of items of some type in your shopping cart, just take it out from your cart. And in each case, if there is, well, if the rule is broken, our code should throw illegal argument exception. Should throw kind of speaks for itself, right? Okay, calculate price. I have all these checks commented out here. Our code will become a little bit bigger, like twice. Yeah, now let's try to rerun our tests real quick. I forgot to unskip one of the tests. Yeah, now I'm hopefully, yeah. Now it's green. Who thinks that everything is fine now? Who knows where the mistake is, if there is one? 2, 3 people. Okay, nobody knows. Let me switch back quickly to my presentation, though. You know, those tests about my code I should be able to remove one thing, to remove two things, I don't know, to remove half of the price, full price, to discount some price. They are very, very similar. And to remove this duplication of code, we could use parameterized tests. Who knows parameterized or data-driven tests? Beautiful, almost all of you. For those of you who doesn't know, it's about passing the whole table of data to our test and running our tests on top of data. Here is how it looks in JUnit 5 in Java. We have some testing method that has method source with some name, string, int, and list provider. Don't hit me, I just copied it from the documentation, official documentation. So I think they think that it's a good code style. And yes, my string, int, and list provider is a static function that returns stream of arguments. Stream of argument 1 includes apple 1 erases list and lemon 2. Well, okay. I have issues with this code, really. I mean, first of all, who thinks that string, int, and list provider is a good name for provider? It's a rhetoric question, don't answer. But the code really becomes cluttered. if you have multiple data-driven tests, we have pairs of my normal test and data provider, and sometimes somebody else puts their own test between my data provider and my test. So it becomes hard to find data provider, and it's not typed because stream of arguments tells me nothing. I don't know what's inside arguments. Are there arguments, ints, strings, arrays, whatever? I don't know. I have to read an actual code, and that's not the way I want to work. And also, provider is bound to our method by a string. And well, I don't like it. I don't like it at all. Because it's Java. Everything should be typed and not stringly typed like in JavaScript. Sorry, JavaScript folks. I don't intend to offend anybody. I just don't like stringly typed things. And this is how it could look in Kotlin with Kotest. They have let's say we have some function, Pythagorean triangle, and we have function with data, and we have all our data in its place, and it's strongly typed because it's a tuple of 3 ints every time. And then inside lambda, we do destructuring of our triple. We can do it another way, but this way it works too. And then we can call our test, our function. And this is like, for me, it's how it should look. For me, it's what is beautiful. And of course, we can try to write a small demo. We are a little bit behind the time, but it will be something like that. Shopping cart, list of. We need one product with some name and some price, and we need its amount. We need discount of type percentage and amount 1. So we'll discard the whole price. Here we will have arguments, our product, items, and discount. What's wrong with them? I'm not sure yet. Yeah, you are right. No, that's correct. I just destructured to two things, but let's try to do it your way. Cart. No, it's still can't infer the type. Did I mess something up with my syntax? Doesn't seem so, doesn't look so. Okay, I don't want to fix it right now, but here I would just put several shopping carts and like this, and we'll calculate price and compare it to something, for example, to 0. Let me quickly remove it to not outrage you. But is it enough? Yeah, I already asked it, and 3 people saw an error in my code. And you know, there is a thing called property-based testing. Who knows property-based testing? Half of the audience, roughly. Nice, good for you. Let me show how it works in Kotlin. This piece of code is already written. So I have another kind of spec. It's fun spec, because everything should be fun in Kotlin. It's language of fun, obviously. So I have this test called hi. I do not care about its name. And magical function checkAll runs property tests. What's a property test? Property test is such a test that tries to put all the nonsense that is possible to put inside our test input and then run function with it. So what we are doing here is we are calling this arp.bind shopping cart, which will just randomly generate kind of valid shopping carts for me. Arp stands for arbitrary, obviously. And then we filter these shopping carts. They should be valid. Valid is, it should not be empty. It should have correct discount, like non-negative and so on. And if it's a percentage discount, it should be between 0 and 1. It should have positive amounts, obviously, and positive prices. What will happen when I will run this test? Nobody knows. Okay. Good, good. Let me run it. It always takes some time because, well, generation of random stuff is hard. Generation of random stuff on my weak laptop, it's already 3 years old, is even harder. But we actually get an error which says, dude, I searched an error. This should be greater or equals than 0, by the way. Of course, inside test, I forgot to tell that we calculate price for our shopping cart, and it should be greater than or equal to 0. This syntax is infix functions. Sometimes we don't need to put ugly dots and breaks around our function arguments. This is just a function that accepts 2 arguments. So yeah, it should be greater or equals than 0. And here is the shopping cart on which we see the error. It's product with this complex name, which we don't really care about, and price something. And flat discount with this amount. So obviously, I forgot to add one test case to my previous set of tests. And actually, it's hard because domain even here is kind of deep. There are lots of combinations of prices and discounts and so on. And it's very easy to forget about one corner case. And that's what I did here. So yeah, usually we use property-based tests for different goal. For example, you need to emulate complex users' behavior and see that your system still operates correctly. It will be just a too complex domain for this particular demo. But you can do the same. And also, yeah, you can reproduce this test. Because each test has its own unique seed which we can put right here. Or not? Okay, Control P doesn't work for me. Okay, tomorrow we can put it there, but it in a spatial object. And then we will be able to reproduce this particular test because in normal situation, property tests fail very rarely. It takes minutes to run them, and it takes some time to find combination that will actually break your system. Here, it always breaks on each seed, obviously, because you will eventually find that flat discounts shouldn't be bigger than total cost of our shopping carts. And this is the second idea I really want you to remember, that property-based testing, is sometimes very simple as that, and it can really find corner cases for you. First times when you will launch it, it will find obvious corner cases. Then they will become less obvious, but still very, very important. Because if automated system found it, your real customer will find it too, and they will hate you. So yeah, now I will be a little bit faster, and I won't live code anymore. So you can relax a bit. Sometimes we need to mock things, and this is some small setup of our thing. We have user service that depends on user repository. Service is some business logic. That's usually user repository is just our layer to work with database. User repository has function all users that returns, just actually throws an exception, and class user is just two fields, string and int. And this is how usually mocking look in Java. First, we create user repository calling makita.mock. Makita is the most well-known, the most popular library in Java for mocking things. And then we pass a class name there. Then we create a list of users that our mock should return. Then we say that Makita, when somebody calls mock repository.allUsers, please return our users created on the previous step. Then we say user service equals new user service and pass our mock repository in there. Then we call user service.getAllUsers, and finally we assert something. It all makes sense, but for me it's very flat. It becomes large when we have larger hierarchies of objects, and it's actually hard to read, in my opinion, when it becomes larger. Again, when it's 6 lines of code, anybody will be able to fit, even me, to fit it into my brain. But when it's 20 lines of mocking, it becomes a little bit more complicated. This is how the same code looks in Kotlin with the mock-k library. First of all, we create users. Nothing is different from what we would do in Java here. Then we mock user repository, but we describe the behavior of mock repository inside Lambda. And if we don't care about implementation details, we can just collapse this block. And we will just know that this mock somehow emulates behavior of our thing. Then we create our service, and obviously call should be on our input. For me, it's a nice DSL. It's very cool that I can describe behavior of user repository inside curly braces. But what if I want to have a deeper mocking? Here, mock-k is better too, in my opinion at least. Sorry. So, I mock user repository. Then I tell the same. Every time when somebody calls all users, I return list of. But here, I just provide mocks, mock case. And Kotlin automatically knows that it's user, it should be an instance of user. Yeah, I shouldn't even put this ugly generic braces, triangle braces. And every time when somebody calls name on the first user, yeah, I return Pasha. The second time it's Alexandra. And then the whole other code is the same. And yeah, obviously I can assert whatever I want to assert. And yeah, thanks Alexandra for helping me with this presentation. Users are described inside user mocks, and it's hidden, and their behavior can be much, much more deeper. It depends on what you need. And also, we do not have to stuck with this cotest assertions should be greater or equal than, because there is a library called Atrium, for example, I like it, that allows us to write assertions this way. It's almost a natural language if you look into it. Expect service get all users to contain in any order, but only entries. And then we assert something about our entries. And yeah, obviously this one will fail, and this one will work on some correct code. And again, it's a deep nesting of assertions. It can be much more readable, in my opinion, because, well, we have granularity to our code. It's not like it's one flat thing, 50 lines of code of checking something. We always have a code block containing only pieces of logic, of assertions we really need. This is how we will see the output of this code. First of all, it will say that I expected subject something and got something. And then it will show you this cross, an element which needs. And then it will show you double red exclamation mark, so you know where to see, because report is big and there is an error in concrete place. User number 3, following elements mismatched. And then we can see what actually mismatched. So it should be equal Pasha, but it was Pasha in the original code. This thing is almost readable as a text, and Atrium itself is totally readable as a text. And as far as I know, it's hard to implement in any other language, in any language other than Kotlin, because infix functions are very beautiful. And it shows errors not just as stack traces, but it gives some meaning to what you see in your error. You have a lot of information to debug, to understand what's going on. It actually describes all the objects we have and what was expected and what we really get. Just for a dessert, this is how our UI tests look. UI tests for IntelliJ IDEA. So it's IDEA test, show BDT panel, it means show big data tools panel. Inside it, there is called create base connection. It just creates a new connection for you in real UI, fills credentials, checks successful messages, and clicks OK. And then it checks that monitoring connection appeared, and this is a nice DSL describing how our UI looks and how it should work. I believe we don't have time to dive deeper into this thing, so for now it will be magic. What did we learn here? First, tests should be readable. What is readable? It's a complex term, but for me it's well-structured and well-understandable tests. Testing is not just unit tests sometimes. Sometimes we have to test more complex things. Sometimes we should think about corner cases we didn't think before. Sometimes we can use property-based tests that would find corner cases for us. Cotests gives good structure to the tests, because you can have your BDD, you can have your JUnit style tests, you can have your fun spec, whatever. Cotest has many flavors that you can utilize in your real project, and hopefully it will help you. And also, Cotest has built-in property-based tests, and they're easy to write. I have more code to showcase. Come to me after the talk, and I will show it. Atrium, as well as many other libraries, gives you nice assertions DSL. And there are many more. And also, I really hope that you found in this talk something that you can reuse either in Kotlin or in your language or with your library. At this point, thank you very much for your attention. Lots of contacts of me. Everywhere. I'm everywhere. Everywhere. And yeah, that's time for questions. Yep.
How to organize this property test? I mean, I would like to read them, write them, and save them, but not execute them in the build phase.
This is a brilliant question. Thank you very much. What I would do, since this whole thing runs on top of JUnit, you can actually tag your test, your property-based test with something like property or whatever tag you want. And then when you run Grail build test and so on, you can exclude your test, and it's built into the JUnit. Thank you for the question. More questions? Yes, Marit.
If it includes property-based testing, does it include mutation testing?
it includes support. It includes support for mutation testing, and I didn't have time to showcase it because suddenly it turned out that I have only 40 minutes instead of 1 hour. Yes, who knows what mutation testing is? Oh, that's so beautiful. So many people know what mutation testing is. But for all others, it's a way to break your code and check that if the code is broken, some tests will fail. It's like, for me, it looks like a tests for tests. And yes, Kotest supports ptest, and ptest supports Kotlin. Thank you for the question. More questions? And it seems we are done.